notes. So we're asked to determine which values of k, if any, will give either a unique solution, no solution, or infinitely many solutions to the following system of equations. So it's a little bit more complicated than usual because here we have not just x, y, and z, which are the variables, but we have this unknown constant k, and how the solution pans out will perhaps depend on k, as we'll see. All right, we're going to proceed just as we usually do. So our solution starts with writing down an augmented matrix. An augmented matrix is, all right, so 1, 1, k, and 2 is the first equation. 3, 4, 2, and k is the second equation. And 2, 3, minus 1, 1 represents the third equation. All right, so we've just written down the coefficients of the x, y, and z on the left-hand side, that part of the matrix, the coefficient part of the matrix, and the right-hand side, 2k1 on the right-hand side there. All right, now we're going to row reduce, just as we usually do. Try to ignore the fact that there's a k instead of a number. So we'll start with this entry here as a pivot entry, and we're going to use it to eliminate the entries in the column below it. All right, so what happens? So we're going to get, this will still be 1, 1, k2. That first row doesn't change. And we're going to take row 2, and our new row 2 will be row 2 minus 3 times row 1. And our new row 3 will be the old row 3 minus 2 times row 1. All right, so we take row 2 and we subtract 3 times row 1. What do we get? 3 minus 3 times 1 is 0. 4 minus 3 times 1 happens to be 1. And 2 minus 3k is, well, it's just 2 minus 3k. That's all we can say. And k minus 3 times 2 is k minus 6. For the third row, we have to take it and subtract 2 times row 1. 2 minus 2 times 1 is 0. 3 minus 2 times 1 is 1. And minus 1 minus 2 times this will be minus 1 minus 2k. We'll just treat the k as a variable whose value we don't know. And finally, 1 minus 2 times 2 will be minus 3. All right, it's a little bit complicated now because there's this k involved instead of numbers, but we're still going to proceed with our row reduction, see what it gets us. So at our next step, we take this 1 as our pivot entry, and we're going to eliminate the 1 below it. All right, so going over here, we're going to have 1, 1. I'll leave a little bit more room here now because it might get a little bit more complicated algebraically. And 0, 1, and here we have 2 minus 3k, and k minus 6. All right, so we're going to take row 3 is going to be row 3 minus row 2. Take this row and subtract row 2 from it. That'll give us 0. 1 minus 1 is 0. And then over here we have minus 1 minus 2k minus 2 minus 3k. Right. So this entry minus this. Well, I think we can do that in our heads. Minus 1 minus 2 will be minus 3. And minus 2k minus 3k will be minus 2k plus 3k for a total of plus k. And then over here on this side, we'll have minus 3, and then we have to subtract k minus 6. So minus 3 minus k minus 6, that's minus 3 plus 6, so it'll be plus 3 and minus k. This thing minus this will be 3 minus k. Okay, and now we are in a position to try to figure out whether or not this thing has solutions, and if so, how many solutions it has. And it will depend on the values of k. So here we have a leading entry, and here we have a leading entry. And this is possibly a leading entry. It will be a leading entry if it is non-zero. So we can say that if minus 3 plus k does not equal 0, then this is a leading entry, and we have 3 leading columns, which means we have a unique solution. So in other words, that's the case when k does not equal 3. Suppose k equals 3. In that case, this entry will be 0, and this entry will also be 0. So if k equals 3, then the last row is all zeros. In which case, we will get a situation where we have 2 leading columns and 1 non-leading column, and then there is an infinite family of solutions because we can set this variable to be a parameter. So if k equals 3, the last row is all 0, and we have infinitely many solutions. Is there any possible way for us to have no solutions? That would be when this is 0 and this is non-zero, which would make this last column a leading column. Well, there's no way of doing that, because if this is 0, this is also 0. So there is no choice of k which gives no solution.